Welcome to science. Yesterday, we talked about simple machines. Can anybody tell me what a simple machine is? Mercedes?
A simple machine is a machine that uses only one movement.
A simple machine is a machine that uses one movement. What's the other type of machine, Estrella?
A compound machine, which is a combination of simple machines.
So it's a combination of simple machines, so it uses more than one movement. Today, we're going to do a lab, and we're going to talk about a simple machine. In your book that you made yesterday, did it talk anything about pulleys?
Yes.
What did it say? What did it say about pulleys? Kelby? What did it say? I wonder where our little, oh, look it. We've got our book.
A pulley is a wheel that is used with a cord or rope. When you pull it downward, the other end lifts upward. Have you ever seen someone hoist a flag up a flagpole? The flag is attached to a rope. At the top of the flagpole is a pulley. When you pull the rope downward, the flag rises up the pole.
That's right. A pulley helps you lift a lot more weight because it kind of disperses things. Let's read about pulleys first. Everybody turn to page 147. We're going to read about pulleys. And I want you to look on the board up here. Here's a picture of pulleys. Do you think that a person just standing there could lift 100 newtons?
No.
No. But with a pulley, it splits that weight in half. Look at here. How many pulleys did they use now? One, two. How much does it split the weight then? In thirds. Look it. So it's 100 newtons. 50, 50, 50. It is splitting the weight. So let's read about it. Let's read about it.
How is that 50, 50, 50 if it's 100 newtons?
We're going to read about it right now,
The
Estrella.
other one, whenever you pull 100,
It's one, well, do you remember about pressure and work? So if am I working right now?
Yes.
No, why? Why am I not
The
working?
table's not moving.
Because the table's not moving. We're talking about when you put pressure and when you put force and something doesn't move, then there's no work. Am I working right now? Yes. Why?
Because it's moving.
I'm pushing force. It's going in the same movement as the force, isn't it? Because remember we talked about the force being with you. Here we go. The pulley. Everybody follow along. To raise a window blind, you pull down on a cord. The blind uses a pulley to change the direction of the force. A pulley, this is one of your vocabulary words. So everybody write down that vocabulary word. Yes. Write down your vocabulary word and the definition. Is an object like a wheel that has a groove with a rope or cable running through it. Thank you. A pulley changes the direction of the input of force. It changes the direction of the force, okay? A rope thrown over a rail can be used as a pulley. A simple pulley, such as the one shown in figure 17, which is also on the board, changes only the direction and not the size of the force. So its mechanical advantage is 1. It is possible to have a large mechanical advantage if more than one pulley is used. The double pulley system shown in figure 17 has a mechanical advantage of 2. Each supporting rope holds half of the weight. See, it's split in half because the force is, or the way of the force is different. This way and this way. That's that's how it's 100 this way, 100 this way, which splits it in half. We're going to read about it. I see some head shaking. Just a second. Each supporting rope holds half of the weight. So the input force you need to supply to lift the weight is half as large as for a single pulley. So it's supporting here. Half of the pulley. So a single pulley changes the direction of the input force. This is one, do you see the arrow here is going down actually? It's heavy, it's wanting to push down. So you're forcing it up. The work is going up, right? The force is going up. And this force you're pulling down. And that, it's hard to understand, but I think with the lab today you will. And so, we're going to talk about the lab. Everybody put your name on your paper.
We still need our book.
Huh?
We still need our book.
No, I don't think, leave your book out so we can refer to it. And we're going to need 3 people in each group. So maybe 3, yeah, 3. This will be a group, and you guys are going to be a group. Please put your name. I know, I just had an epiphany about force. We talked about it yesterday, Estrella. And this is how we can explain it mathematically. Look, do you remember yesterday when they gave us, yes, what do you need?
What's an epiphany?
Oh,
Like
an
when
epiphany.
When you realized you did something.
Exactly, Jordan's right. It's like you go, oh, I just had a great idea. It's an epiphany. I just realized something. So look. Mechanical advantage equation. Bam. Oh, here. Sorry, guys. There you go. Okay. If you recall, in math, we've been studying about rate equals time over distance, right? That's how we figure out how fast something is going. Well, in science, they have these awesome equations that tell us things as well. So, here we have mechanical advantage. I'm going to call it MA, okay? Mechanical advantage. So, pulleys help us have a greater mechanical advantage, right? Instead of just picking something up. Mechanical advantage equals force out.
Do we need to write this down?
You do not need to write this down. In newtons. Because we have to say what it's in, right? Over force in newtons. Okay? Yes?
What does it mean by force out and force in?
I'm about to tell you what force out and force in means, okay? We're going to go back to mechanical advantage, okay? When you push on the handles of a can opener, the force you apply is called the input force. So does everybody remember our picture yesterday of the can opener? opener, and the force in is this motion that you do with your hands, okay? This is how a can opener is a simple machine that helps us. The force out, then the can opener changes your input force to the force that is exerted by the metal cutting blade on the can. The force exerted by the machine is called the output force. So, I'm going to slide this up a little. Watch. I'm going to draw our can opener again. Okay. It's such a good drawing. So this force that we put when we squeeze the handles together is what? Input force? The input force. And the force that is when that little metal wheel crunches into your can, that's the output force. So this is the input force. And this is the output force. See? All right, so that's how a pulley works. Let's go back up here to our little drawing. The input force and the output force. Yes, you may. This, you remember how it just now talked about if you threw a rope over the rail of a fence, that acts like a pulley because look, here's my input force and that's my output force is where it's coming up. It's changing the direction of the force. I'm pulling down, the object is coming up. Different directions of force. No, watch. This is how we're going to test pulleys and input force and output force. We're going to need some volunteers. Stephen and Andrea.
Oh, that's just lined up.
That is. Come on up. So here's one person is going to hold this side. One person is going to hold this side. The third person, if you can't see, come and stand like around where you can see. Or let's twist like right here. We're going to twist. Okay, you got to face each other. Okay. Got to face each other. There you go.
Turn this way.
We should turn this way. Okay, so everybody can see? Okay, come right here, you two. Right here. There you go. Okay, watch. Hold it real tight. Hold it like with all your muscles. Yes, just like she does. Just like she's doing. Okay, watch. If I try just go against me, if I try just to push these together, I can't. They're much too strong. I can't push that together. Okay, relax. Okay, we don't want anybody to go flying, so be very careful. If I take this rope, because I'm going to use it like a pulley to change the direction of my force, I'm going to wrap it around one time. Now watch what happens. You see how I can pull together? Okay, watch. Now, keep going. Okay, good. Apart a little bit. Stop. That was just one wrap. Look at your graphic organizer. It says one wrap. What else does it say? Two wraps. Let's try it. Okay, you guys. Ready? You see how I can pull that together then? Even easier. Okay, let's try. Oh, sorry. So, ouch. Got to keep it straight so it doesn't tip. Then what's it say? How many? 8. 8 or 2 times 8 times. Let's do it.
No.
Let's see. I think
It says 4 before 8.
It says 4 before 8.
Yeah.
Does it say 2? Did I just miss?
It says 2,
It
4,
didn't
8.
say 2.
It says 4, 2, and 8. It says 4, 2,
4, 2, and 8. Okay. Now we'll do 8. Ready?
Oh.
Let's see how tough these guys are. Okay.
Back with your body.
Okay, I think you're going to have to come together just a tiny bit. Thank you, sweetie. So 1 wrap, 2, whoops, we don't want them crossing, 2 wraps, 3, might have to get closer together, 4, you know what? I just decided I'm going to let you guys try it. I don't need to demonstrate this. I want you guys to try it. Okay? So, get in your groups. I'm going to bring you your rope and your pulleys and your sticks. Okay?
I got my
I'm
own
holding
one.
one. I'm holding one.
Me too. No, give me it.
Okay.
Just do it. It's actually mine.
Don't forget to record your information.
Wait, Steven, give that one to her.
Who's missing one? Who's missing one? Oh, we just need a rope.
Where's the rope?
What am I going to get to do?
This one's not
Okay.
Do we all read it like 4 times?
Absolutely. If you all 3 want to try Darian and Cooper. Do you want to be in my group? Do you guys want to be in my group? Darian and Cooper, come on. Do not forget to record your information on your lab.
Well, first can't.
I have to make sure it's the recorder on hers. We just like, okay. Yeah.
What?
And some of us will talk after you in a minute. Okay, now it's Steven's turn.
2 times.
Be very careful and be very aware of your classmates. We wrapped it once. No.
I would so do that.
Hurt your classmates. Okay. Ready?
Come up here to your mom.
Okay.
No, it goes under. It goes under now. Under?
Okay, grab it right here, Darian.
No, that's. That's going to that one too.
I get so like, can we? Yes, no. Like it isn't bad. Stop it.
Let's write that down. Yes, we will let you know.
Right now, burn my. See what it burned me the last time.
Okay, now Jane.
So what'd you guys think about that one? That was easy too. Okay, Debbie, guys.
Okay, we'll try.
Okay, really?
That was easy too.
I want to be
Yes. Group, look at me. If I see you messing around with your pulleys and your rope, then perhaps you'll just have to watch and not participate, okay? You'll just have to write your observations down. Also, this group right here came up with a good idea, which I think is very good. If you want to write from the point of view of the person holding and from the point of view of the person pulling, you can write both those points of view on your lap, okay? So come on back in, fellas. Okay. Wrap it twice.
Oh no!
So which one was the easiest? The 8. Okay.
I heard my
want to do the one with the. I want to do the 8.
You do too.
Your veins. What needs to be
You want to do the 8 this time? No, I want. Let's let him do it.
Okay. Now Raz.
Kevin, you want to do the rope next time?
Yeah, let's do it. We should set this
Easier? That was. Okay.
Just write your thing.
Okay, we'll write it. Yeah, write it, and then we'll do it 8 times. Also, look at this. Okay, watch.
We almost had it. No.
Group, it's easier to wrap your, it's easier to wrap if you start like this and then count. Look, watch. Put them together. 1, 2, 3, 4, 5, 6, 7, 8. Then kind of slide them together. And then work them apart a little bit. Okay? Try that. Are you ready, Gary?
Kind of hard.
Yeah, you do.
Yeah,
Here, let me do it this way. 1, 2, 3, 4, 5, 6, 7, 8.
this way.
Okay, now let's work it apart a little bit.
2, 3, 4. Wait,
Too close.
count. 1, 2, 3.
Pull apart. Me and Steven apart.
Can't. She's tied it too much and too tight.
Hold on. I got this.
Super easy.
Oh, wait, no. Just put on 8 like that.
Stop it,
Just like
Jaden.
that. There.
Yeah, it was super easy instead of easy.